let's look at the CPU core as a block diagram. So a high-level block diagram of what we've implemented. So we have a few units in our CPU core responsible for different things. So the first thing that we need to do is we need to have a program counter. You saw the blue arrow in the visualization. So the program counter keeps track of the instruction that we need to fetch from the instruction memory. So we use that PC to index into the instruction memory, grab the instruction, and return the instruction. That's coming back, of course, as a string of bits. We have to interpret those bits and do something with them, and that's the decoder that we saw. So the decode logic is responsible for figuring out what type of instruction is this, what registers is it going to operate on, where is it going to write the result. And then, so once we've decoded and figured out what registers we're operating on, we need to read those registers from the register file. The register values come out. Let me grab my pointer here. The register values come out and go into the arithmetic logic unit. So for arithmetic instructions like an add, we're going to operate on those two source registers. In the case of an add, of course, perform an add and produce a result, and that result is going to circle back and write into the register file in the appropriate index specified by the instruction. Down here in gray, I've showed data memory. It's in gray because, as I said, we're not going to do anything with the data memory. We're not going to implement the data memory, but generally the CPU would have access to data in memory as well. We're also going to support branch instruction, as you saw. You saw the branch less than instruction. And for the branch instruction needs to adjust the program counter. So there's an immediate field in the branch to specify the offset for the PC. And we apply that offset by adding that offset to the PC and then applying that new adjusted PC value to the PC. And that provides the PC for the next instruction that we're going to fetch. Alright, so this is a very simple CPU architecture. Generally, a CPU is going to be pipelined, meaning these various operations are going to happen over several cycles of the CPU clock. In our case, we're doing a very simple implementation. Our implementation is going to do everything in a single clock cycle. Alright, so let's jump forward and look at how we're going to implement our CPU core. So some of the components of the CPU we're providing for you. We're providing the program counter and the increment logic for the program counter. We're providing the instruction memory pre-populated with the program that you just saw. And we're providing the register file. And you're going to create the logic for the decoder, the branch target update, and the arithmetic logic unit. Alright, so let's relate this high-level block diagram with what you'll see inside MakerChip as you design your CPU core. So again, we're looking at the complete implementation of your core once you're finished with the tutorial session. And you'll see a logic diagram inside MakerChip that will look something like this when you're done. So relating to the high-level block diagram, our CPU core starts off with program counter logic. We create a program counter signal that points into the instruction memory. So this is the read address of the instruction memory being driven by our program counter, used to index into the instruction memory, which is depicted here, to grab the instruction. So the instruction memory read data is the instruction. And that instruction gets sent all around to the decode logic to interpret those instruction bits and do the appropriate thing with them. So somewhere here, here it is, we have our result. So this is the output of the arithmetic logic unit. Right? So our instruction is going to get decoded. It's going to access the register file, which is depicted down here. And the value coming back from the register file will end up getting fed into the arithmetic logic unit, which is producing this result expression. And I think if we sort of chase signals around here, we'll see where these are actually hooked up. So you can see here the data coming back from the register file for one of the source registers, the source 1 register in this case. Its value getting fed to the arithmetic logic unit, which is entirely this result expression, producing our output that then goes back to the register file.